Alright, so we're on problem 521, and with this problem we're going to look at Madison Dairy Ice Cream, and we're going to look at how we're going to forecast out what it's going to cost them to produce what they want to produce. And so they have four different kinds of ice cream, and they give us the sales volume on how much they want to produce of each one of these kinds. And so this problem is actually, it goes to problem 181 to 184 in the book. And so most of the information for this problem is back in the chapter. The only thing that's different from the problem in the chapter is this stuff right here. So we've got different sales volume and different number of production runs. And so I just went into the chapter itself and just copied in some of the tables from the chapter. So there's a lot of information to sort through on this one, but we'll just break it down in small chunks so it's not too overwhelming. So to forecast our cost, we basically have two different kinds of costs. We have our labor and we have our machine cost. And so in part A, it says, assuming that only full-time employees can be hired, determine the number of production employees required to meet this production plan. We also want to figure out how many machines do we need. And so essentially what we're going to do here is, based on what their plan is, we're going to look at what the ideal cost would be, and then we're going to look at what the actual cost could be. And those are going to be different because we're going to hire so many employees, we're going to have so many machines. And so we're going to have those employees and those machines in place when we start. Then we're going to look at, and so the cost we're going to get is going to be an ideal number of hours that we need and machines that we need. However, we're probably going to have more employees than necessary and more machine hours available. So by looking at the difference between those two, we'll be able to understand kind of what we're losing, for being, slightly inefficient. So in this problem, we'll start off with labor, and we want to figure out the indirect labor for the number of runs. And so this information is given. So the number of production runs for each one of the chocolate, or each one of the ice creams, are right here. So 18 for vanilla, 16 for chocolate, and so on. And then it gives us the handle production run hours down here, so 2.5 hours each. So we just multiply these. So yeah, that gives us the indirect labor for the handle runs. And then now we'll look at the setup time. And so all this information is given as well. So we have the setup time per run, and so that's given right here. And then the number of employees per changeover, that's given to us as 2. So we multiply those together to get the indirect labor hours per run. And then also we have our number of production runs, which we already know are up here. So we're just going to multiply our indirect labor hours per run times the number of runs. And then the indirect labor to maintain products, that's 8. That's already given to us down here. So we'll sum those up. And so that'll give us total indirect labor hours. So we have our 45 plus our 72 plus our 8. Alright, so that is going to be the total indirect labor hours. So 273.7 total divided by each one of our products. And so now we want to look at the direct labor. Let's put a sum in right here. The total gallons that we're going to make. It says that the direct labor hours per gallon is given, so that's down here in this table, direct labor hours per gallon. So we can just multiply that. Drag that across. Add in our total. And so that's the total direct labor hours. And so for the total that's going to be the indirect plus the direct. And so the total number of hours it's going to take, both direct and indirect, to make all this ice cream is going to be just over 1,000 hours. And so given in the problem, it tells us that each employee has about 133 productive hours in them each month. So if you're, hey, how many employees do we actually need? And so if we take the total hours divided by our 133, that gives us 7.9 employees. But we obviously can't hire just 0.9 of an employee, so we're going to have to round that up. So we can use the round up function. And so 7.9 employees obviously rounds up to 8 full-time employees. So we really need 7.9 employees, but we're going to have to hire 8. Alright, so the next part for machine hours, and so we have the total production volume, which that's up here, and we have the machine hours per gallon, so that's down here in one of our tables. So yeah, machine hours per 1,000 gallons. So if we take our total gallons, divide it by 1,000, because it's 4,000 gallons, multiply it times the machine hours. Put in our total. So that's the total machine run time. And then we have our number of production runs. So that's given to us, the setup time for each one of these runs. So just multiply this. So our total machine hours, so both for runtime and setup time, for each one of our different kinds of ice cream, and in total. And so it, given in the problem, it says that the productive hours per each machine is going to be 154 hours. And so if we put in a round function here, that means that we need 3 machines to make all this ice cream. Alright, so now we've identified all of the labor hours it takes to make the ice cream, and we've identified all the machine hours it takes to make the ice cream. So now we can put together our kind of pro forma income statement. And so start off by our selling price, and our selling price is listed over here for each one of the kinds of ice cream. So vanilla and chocolate are both $2.90. Strawberry is $3.40, and our mocha almond is $4 per gallon. It looks like we have it gives us our weighted average already at $2.96. Our sales volume, we already have up here, so we can plug that in. And so our revenues is just going to be the selling price per gallon times the number of gallons. So now we have our total revenue in whole and by our different kinds. And so now for our expenses, so it says the direct material cost is going to be $600 per 1,000 gallons. So we know what our total gallons are. Divide that by 1,000 and then multiply it times 600. And for our direct labor, it says that for every 1,000 gallons, it's going to be $875. And for our indirect labor, so it tells us in the problem here somewhere that the indirect labor rate, it might be in the text itself and not in a table. Anyway, it gives this to us at $35 per indirect labor hour. And so we know the total indirect labor hour are over here. Whoops. Put an equal sign here. So 35 total indirect labor. All right, here we go. There we go. So now we have our total indirect labor cost. And then our machinery cost in the problem, it tells us that it's $50 per hour times our total machine hours, which is right here, total machine hours. And so that gives us all our expenses. So to figure out gross profit, we take our total revenue, and then we're gonna subtract all of our expenses. In our gross profit percentage, we just take our gross profit, divide that by our total revenues, gets us our gross profit percentage. And so based on our ideal situation, if we're really efficient, we would make $16,206 in gross profit and have a profit margin, or gross profit margin, of 17.5%. But in part C, it says, what's the company's gross profit ratio if we factor in unused capacity? So it's so hard to match what we're actually going to do versus the capacity that we have on hand. And so, excuse me, they're never going to match up perfectly. And so it tells us in the problem that there's 8 employees, and their productive hours are 133 per month, and they have a rate of $35 an hour. So 8 employees for 133 hours at $35 an hour is going to be an actual labor cost of $37,000. Our actual machine cost, says we're going to have 3 machines. Their productive hours are 154 hours a month, and that gives us a rate of 50. So we just multiply that out. So the actual machine cost is going to be $23,000. So we're going to have our actual cost is going to be the total labor and the total machine cost, so $60,000. But our ideal cost, we calculated up here, is going to be the sum of all 4 of these, so our direct and indirect for labor and machine. Whoops. We're not factoring in direct materials. We're just factoring in labor and machinery. There we go. So that means the actual cost that we're going to incur is going to be the $60,000, but our ideal cost would be $57,000. So we have an inefficiency here of $2,600. So if we take our original gross profit, which is right here, and we add in our inefficiency adjustment, that's going to give us our new gross profit of $13,528 and our new gross profit margin of 14.6%. So we have the ability to have a gross profit margin of 17%, but what we're actually going to have is more of a 14.6.